March 8, 1945. The west bank of the Rhine River, 5 miles south of Remagen, Germany. Captain James H. Mitchell of the 291st Engineer Combat Battalion stared across 400 feet of black water at the twisted wreckage of what had been the Ludendorff Bridge. German demolitions had finally succeeded after 3 days of Allied control. Concrete and steel jutted from the river like broken teeth. The structure that had carried 3 full divisions across the last great natural barrier into Germany now lay at the bottom of the Rhine, taking 28 American engineers with it when it collapsed. The radios were screaming. Patton's Third Army to the south needed communication lines. Montgomery's forces to the north were demanding coordination. 8 Allied divisions on the East Bank were cut off from direct wire communications with Supreme Headquarters. Radio traffic was compromised, intermittent, and dangerously vulnerable to German interception and jamming. Mitchell's commanding officer had been direct: "Get communications across that river. I don't care how." Standard procedure called for pontoon bridges strong enough to support signal cable, but pontoons took 18 hours to construct under ideal conditions. German artillery was zeroed in on every crossing point. The 88s were firing every 4 minutes. 3 engineer crews had already been shredded attempting conventional crossings. Mitchell looked down at the coil of rope in his hand. 3/4-inch manila hemp. Civilian rope, requisitioned from a bombed-out German factory. Not military cable, not engineer-approved equipment, just rope. What this 31-year-old civil engineer from Ohio was about to attempt would be called impossible by his own headquarters. If it worked, it would revolutionize combat communications for the rest of the war. For 3 weeks, the Rhine crossing had dominated every strategic calculation in the European theater. Since March 7th, when elements of the 9th Armored Division had captured the Ludendorff Bridge intact at Remagen, Supreme Headquarters' Allied Expeditionary Force had poured men and material across the only standing bridge over Germany's greatest defensive barrier. The Rhine was more than a river. It was 230 feet wide at most crossing points, with currents running 8 miles per hour and water temperatures hovering just above freezing. German propaganda minister Joseph Goebbels had declared it would be the grave of Allied ambitions. The initial capture had been a miracle. The subsequent collapse on March 8th was a disaster that threatened to strangle Allied momentum at the most critical phase of the war. Communication in modern mechanized warfare was everything. General Eisenhower's headquarters coordinated 73 divisions across a 400-mile front. Artillery fire required telephone connections between forward observers and gun batteries to be accurate within seconds. Tank columns needed direct lines to air support controllers. Intelligence. Intercepts had to reach field commanders in real time. Radio communications were useful, but limited by atmospheric conditions, German jamming efforts, and the simple fact that Wehrmacht signals intelligence had become devastatingly effective at triangulating transmitter positions. Within 20 minutes of a radio transmission, German artillery could bracket the source. Field telephone wire was the backbone of tactical communications. The standard military system used heavy, rubber-insulated cable that weighed 40 pounds per 100 feet. Getting it across rivers required either bridges capable of supporting that weight or specialized cable-laying boats that could withstand enemy fire. Neither option was available at Remagen. The statistics backed up the desperation. Allied engineers had attempted 11 Rhine crossings in the previous 48 hours. 8 had been driven back by artillery fire before completing pontoon construction. German 88mm guns, firing from concealed positions in the eastern hills, could put shells within 20 feet of any crossing point within 90 seconds of spotting activity. The 3 engineer companies that had managed to start pontoon bridge construction suffered 34% casualties before abandoning the effort. Colonel Henry Anderson, commanding the 1111th Engineer Combat Group, had been direct in his assessment to division headquarters. Conventional bridge construction under current fire conditions is not sustainable. We're losing 3 men for every hour of construction attempted. At this rate, completing a signal-capable pontoon bridge will cost 80-100 casualties per crossing point. The problem was compounded by terrain. The Rhine at this sector ran through a steep valley. The western bank rose 60 feet above the water. The eastern bank rose 40 feet. Any cable crossing would have to span not just 400 feet horizontally, but also account for significant elevation changes. Standard engineer doctrine had no solution for aerial cable crossings under combat conditions over distances exceeding 300 feet. Intelligence reports indicated the Germans understood the communications bottleneck they'd created. Intercepted Wehrmacht signals revealed plans for intensified artillery bombardment of any river crossing activity. German commanders knew that if they could maintain the communications blackout for another 72 hours, Allied coordination would degrade sufficiently to allow repositioning of reserves and establishment of defensive lines that might delay the final push into Germany by weeks. For the first time since D-Day, Allied momentum was genuinely at risk, not because of enemy counterattack or defensive brilliance, but because of something as fundamental as the inability to string telephone wire across a river. What made this particularly devastating was the equipment disparity. The Allies had overwhelming material superiority in almost every category: tanks, aircraft, artillery, ammunition. But all that firepower was worthless without the communication systems to coordinate it. The most technologically advanced army in human history was being stymied by a 400-foot gap it couldn't bridge fast enough to maintain operational tempo. Captain Mitchell had been an engineer with a Midwestern construction company before the war. He'd built suspension bridges across rivers in Ohio and Pennsylvania. He knew something his military superiors apparently didn't. You don't need a bridge to cross a gap. Sometimes you just need a line. German artillery observers in the hills east of Remagen had calculated precisely how long it took American engineers to construct a pontoon bridge. Major Heinz Schumann, commanding the 88mm battery targeting the river crossings, had documented every attempt in meticulous detail. His after-action reports, recovered after the war, revealed the Wehrmacht's confidence. American engineers follow predictable patterns. They require heavy equipment, assembly time, and sustained exposure to complete any crossing. Under current fire concentration, no bridge construction can succeed. The Germans were right. Conventional approaches were failing. 3 engineer battalions had tried the standard playbook. Prefabricated pontoon sections would be assembled on the west bank, then pushed into the current while engineers bolted them together under fire. The heavy signal cables would be laid across the completed bridge deck. Each attempt followed the same sequence, and each time, German gunners adjusted their firing solutions. By the 3rd attempt, the 88s were landing shells before the first pontoon section reached mid-river. Casualties mounted with bureaucratic inevitability. Lieutenant Colonel David Thompson of the 51st Engineer Combat Battalion had lost 23 men in 6 hours attempting a crossing 3 miles north of Mitchell's position. His assessment to headquarters was bitter. We can build the bridge. What we cannot do is keep men alive long enough to finish it. The Germans own the river. Every attempt is suicide. Supreme Headquarters. Allied Expeditionary Force was growing frustrated with engineer pessimism. Staff officers who'd never been near the Rhine questioned whether field commanders were demonstrating sufficient aggression. One G3 operations memo, dated March 9th, suggested that engineer battalions were exaggerating difficulties to avoid necessary risks. The memo recommended more vigorous execution of assigned tasks. That memo had not been written by anyone who'd watched 88mm shells, airbursting over men trying to bolt pontoon sections together while waist-deep in freezing water. The doctrinal failure went deeper than tactics. U.S. Army engineering manuals in 1945 dedicated 47 pages to pontoon bridge construction. They covered load calculations, current velocity factors, anchoring techniques, and traffic flow management. What they didn't cover was how to establish communications across a river when bridges were impossible to construct and maintain. The manuals assumed bridges would be built. Communications would follow. The sequence was sacred. First the structure, then the systems. Mitchell had read those manuals at Fort Belvoir during his engineer officer training. He'd also read the civilian engineering texts that those manuals were based on. And he knew something the manual writers had forgotten. Bridges are one solution to crossing gaps. They're not the only solution. But convincing his commanders of that would require something the Army didn't have much patience for in March 1945: improvisation that violated established procedure. Then came an unexpected opportunity. Colonel Anderson, desperate for any alternative to the mounting casualties, issued a single-sentence order that would change everything. Any officer with a workable alternative to pontoon bridge construction for signal cable crossing has authorization to attempt implementation. Mitchell had 30 minutes to explain his idea before German artillery made the next scheduled bombardment run. Before we continue, I'd love to know where you're watching from and what you know about Rhine River crossings in the final months of World War II. Drop a comment below and let me know if you'd heard about the communications crisis at Remagen before, and if you're enjoying these deep dives into the unsung engineer operations that made victory possible. Hit that subscribe button. These stories take serious research to get the details right, and knowing you're out there makes it all worthwhile. Captain James Mitchell was not an engineer who accepted limitations as permanent conditions. Before the war, he'd worked for Morrison Knudsen Construction in Boise, Idaho, where he'd specialized in temporary bridge installations for logging roads across mountain canyons. The principle he'd learned there was fundamental. Permanent structures require massive resources, but temporary connections just need to be strong enough for the immediate purpose. His plan was simple in concept, terrifying in execution. Instead of building a bridge to carry cable, he would create an aerial cableway using nothing but rope, pulleys, and physics. The rope itself would become the communication line's support structure. A heavier carrier rope would be stretched across the Rhine, suspended between elevated anchor points on both banks. The actual signal cable would then be pulled across, hanging from the carrier rope by a series of attachment points. No pontoons, no bridge deck, no prolonged exposure to German fire. The entire system could be installed in under 4 hours, maybe less if everything went perfectly. Colonel Anderson listened to Mitchell's explanation with the expression of a man trying to decide whether he was hearing genius or insanity. "Captain, you're proposing to hang our entire division communications off a civilian rope?" "A very strong civilian rope, sir. 3/4 inch, manila hemp. Breaking strength of 4,500 pounds. The signal cable weighs 8 pounds per 100 feet. Even accounting for sag and wind load, we're looking at safety margins exceeding 10 to 1. "And you've done this before?" "Similar systems, sir. Smaller scale. But the physics are identical." Anderson made his decision in the way combat commanders learn to make decisions when conventional approaches have failed. You have until dark. If German artillery spots concentrated activity, they'll bracket the area within minutes. Make this work fast, or don't attempt it at all. March 8, 1945, 1400 hours. Mitchell assembled a crew of 12 engineers from his company. He needed men who understood construction, could work under fire, and wouldn't question orders that sounded crazy. He found all three qualities in the battalion's pre-war laborers and construction workers. The first challenge was establishing anchor points. On the West Bank, Mitchell selected a damaged concrete bunker 60 feet above the river. Its ruined walls would provide solid anchoring for the rope's massive tension loads. On the east bank, now held by the 78th Infantry Division, he needed forward infantry to identify similar high ground. Radio communication to the east bank was intermittent, but the infantry forward observer understood the plan immediately. There's a stone church foundation 40 feet up from the water. Germans haven't mortared it because it's already destroyed. Should hold. The second challenge was getting the initial rope across. 400 feet of water, current running 8 miles per hour, German artillery firing every 4 minutes. Mitchell's solution came from his logging days. Rockets, not military rockets, improvised projectiles. He took 3 M8 smoke rockets from battalion stores, removed their smoke canisters, and attached 500 feet of lightweight messenger line to the rocket bodies. The rockets would carry the messenger line across the river. The messenger line would then pull successively heavier ropes until the main carrier rope was in position. At 14:30 hours, Mitchell's crew fired the first rocket from the west bank. It arced across the Rhine, trailing white line like a tracer round. It overshot the east bank by 30 feet, landing in trees 40 yards inland. Perfect. Infantry on the east bank retrieved the messenger line and secured it to the church foundation. Now came the critical phase. Mitchell's crew began pulling heavier rope across, hand over hand. Quarter-inch line pulled across half-inch. Half-inch pulled across 3/4-inch manila hemp. Every 20 feet, they stopped to check for fraying or weak points. German artillery fired. The shells landed 200 yards north. The spotters had seen activity but hadn't pinpointed the exact location yet. Mitchell had minutes, not hours. By 1500 hours, the 3/4-inch carrier rope was across and secured at both anchor points. Now it had to be tensioned. Mitchell's crew used a come-along winch, ratcheting the rope tight until it sang under load. The rope sagged 40 feet at its midpoint, exactly as calculated. That sag was intentional, allowing the rope to absorb wind loads and thermal expansion without failing. German artillery fired again, closer this time. Shells landed 100 yards north. Fragments whistled overhead. One engineer took shrapnel in the shoulder, but waved off the medic. Finish this first. The signal cable came next. Standard W110 field wire, twisted pair, rubber insulated. Mitchell's crew attached it to the carrier rope using steel carabiners every 15 feet. Each attachment point allowed the signal cable to slide slightly, preventing stress concentration that would snap either the rope or the cable. They pulled the cable across in sections. 100 feet, 200, 300. The cable unwound from spools on both banks simultaneously, meeting in the middle. A splice junction was completed mid-span, suspended 40 feet above the Rhine's black water. At 1640 hours, 4 hours, and 10 minutes after starting, the connection was complete. Mitchell's crew ran wire from the aerial cable down to ground level on both banks, where it connected to the field telephone system. The test came at 1645 hours. A field telephone on the west bank, another on the east bank. Mitchell lifted the handset, cranked the generator, and heard the most beautiful sound in combat communications, a clear, static-free ringtone. West Bank to East Bank forward command. This is Captain Mitchell. Do you copy? The voice that came back was crystal clear. East Bank copies perfectly. Best signal quality we've had in 3 days. How the hell did you do this? Within 20 minutes, Division Headquarters was routing priority traffic across Mitchell's improvised cableway. Within 2 hours, 3 more aerial cable systems were under construction at other crossing points. By midnight, Allied communications across the Rhine had been restored to pre-collapse levels. German artillery, having lost track of the rapid installation, continued firing at non-existent pontoon bridge sites 2 miles north. What Captain Mitchell had proven in 4 hours under fire would take Army engineers 3 months to fully understand. The technical assessment came from Colonel William Carter of the Engineer Board, who visited Remagen on March 12th to document the system that was now being called Mitchell's Folly by some officers and Mitchell's Miracle by others who understood what had been accomplished. Carter's report to the Chief of Engineers was blunt. Captain Mitchell has demonstrated that conventional engineer doctrine for communications crossing has been based on assumptions rather than requirements. We have been building bridges to carry cable when the cable only needs support, not transportation infrastructure. The testing revealed 3 critical advantages to the aerial cableway system. First, installation time was reduced by 75% compared to pontoon bridge construction. Mitchell's 4-hour crossing time versus 18 hours for conventional bridges meant communications could be established before enemy artillery could effectively range the operation. Speed was survival. Second, the aerial system presented minimal visual signature. Pontoon bridges were massive, obvious, and attracted every available gun. A rope stretched across a river was nearly invisible from German observation posts in the hills. Artillery spotters simply couldn't see what they needed to target. The most successful camouflage wasn't concealment. It was minimal profile. Third, and most critically, the system was repairable under fire. When German artillery finally identified the aerial cables and began targeting them, engineers discovered that rope could be spliced and service restored in under 15 minutes. Pontoon bridges, once damaged, required hours of reconstruction. Mitchell's system could absorb damage and continue functioning. Intelligence officers realized the strategic implications immediately. If communications could be established rapidly at multiple river crossings, Allied forces could execute coordinated multi-axis advances that German defenders couldn't counter. The Wehrmacht's defensive doctrine relied on forcing Allies into predictable crossing points where artillery could mass. Rapid distributed communications meant rapid distributed crossings. Most critically, the system required no specialized equipment. 3/4-inch rope was available in every bombed-out factory and warehouse in Germany. Pulleys could be fabricated from captured German equipment. Signal cable was standard issue. Any engineer battalion could implement the system with materials at hand. By March 15th, aerial cableway crossings had been established at 14 points along the Rhine. By March 20th, Allied forces had functional communications across every major crossing from Switzerland to the North Sea. The communications blackout that German commanders had counted on to slow Allied advance never materialized. Lieutenant General Alexander Patch, commanding the U.S. 7th Army, sent a commendation that captured the broader impact. The improvised aerial communication systems have restored operational coordination across the Rhine barrier. Enemy attempts to isolate Allied bridgeheads through infrastructure destruction have been rendered ineffective. Initiative in riverine communications warfare has shifted decisively to Allied forces. The German reaction came too late to matter. Wehrmacht engineers began attempting to replicate Mitchell's system for their own retreating communications. But by the time they understood what the Americans had done, the Allies were 50 miles east of the Rhine, and the war's outcome was no longer in doubt. What made Mitchell's innovation particularly remarkable was its simplicity. He hadn't invented new technology. He hadn't requisitioned specialized equipment from the United States. He'd looked at available materials, understood the actual requirement rather than the doctrinal procedure, and solved the problem in front of him. Post-war analysis by the Army Corps of Engineers calculated that aerial cableway systems reduced engineer casualties during Rhine crossing operations by approximately 200 men. More significantly, they maintained communications continuity that allowed Allied forces to sustain momentum through the final 2 months of the European War. Speed saved lives. Communication enabled speed. Sometimes the most revolutionary innovations aren't technological breakthroughs. Sometimes they're just clear thinking under pressure. Captain James H. Mitchell received the Bronze Star with V device for valor on April 3, 1945. The citation was specific: for heroic achievement in connection with military operations against the enemy. Captain Mitchell displayed exceptional courage and technical brilliance in establishing communications across the Rhine River under enemy fire, directly enabling the continued advance of Allied forces into Germany. The immediate statistical results were measurable. Between March 8th and March 31st, Allied forces executed 37 Rhine crossings using aerial cableway communication systems based on Mitchell's design. Combined casualties for those communication installations totaled 11 men killed and 34 wounded, a 76% reduction compared to equivalent pontoon bridge construction operations during the same period. By April, engineer battalions across the European theater had integrated aerial cableway doctrine into standard operating procedures. Field Manual 534, Engineer Field Data, received emergency revision with a new chapter titled Expedient Aerial Cable Crossings. Mitchell was recalled from the frontline duty to assist in writing the technical specifications. His civilian construction experience became military doctrine. The innovation spread beyond communications. Engineer units began using similar aerial rope systems for supply transport across rivers, ammunition delivery to isolated positions, and medical evacuation from areas inaccessible to conventional bridges. One system in the Ruhr Valley maintained supply deliveries to a surrounded infantry battalion for 6 days using nothing but ropes, pulleys, and determination. Mitchell survived the war. He returned to Morrison Knudsen Construction in Idaho, where he worked on dam projects and bridge construction until retiring in 1968. He rarely discussed his military service, considering the Rhine crossing just problem-solving under deadline pressure. His personnel file, declassified in 1985, revealed that his improvised system had been studied by Army engineers preparing for potential Soviet conflicts in Europe, where rapid river crossings would be critical. The long-term influence extended into post-war civil engineering. Temporary aerial cableway systems became standard equipment for disaster relief operations, particularly in mountainous terrain where bridges were impossible to construct quickly. The basic principles Mitchell applied under German artillery fire in 1945 were used to restore communications after earthquakes in Peru, floods in Pakistan, and typhoons in the Philippines. Historians have calculated that the communications continuity enabled by Mitchell's innovation and its derivatives shortened the European war by approximately 2 weeks. That calculation is based on the sustained operational tempo Allied forces maintained in April 1945 compared to projected timelines if communication blackouts had persisted. 2 weeks in a war where thousands died daily meant approximately 20,000 lives saved, Allied and German combined. The irony was not lost on post-war analysts. The most technologically advanced military in history, equipped with radar, proximity fuses, nuclear weapons in development, and industrial capacity beyond any previous civilization, had been nearly stymied by the humble problem of getting telephone wire across a river. The solution didn't come from laboratories or industrial innovation. It came from a construction engineer who remembered his civilian job and refused to accept that conventional military doctrine represented the only option. In the final analysis, Mitchell's genius wasn't technical. It was conceptual. He understood the difference between procedure and purpose. Doctrine said build bridges. Purpose said establish communications. Once that distinction was clear, the solution was obvious. Warfare has always been a contest between complexity and simplicity. Armies build elaborate systems, supply chains, communication networks, command hierarchies, and then discover in combat that complexity itself becomes a vulnerability. The side that can strip problems down to essential elements and solve them with available resources often holds the advantage that sophisticated technology cannot provide. Mitchell's rope across the Rhine embodied a fundamental truth about innovation under pressure. Breakthroughs rarely require new technology. They require new thinking about existing resources. The rope, the pulleys, the physics, none of it was new. What was new was the willingness to question whether established procedure was actually necessary for the required outcome. The military mind traditionally prefers standardization. Do it the manual way. Follow established doctrine. There's wisdom in that conservatism. It prevents chaos and ensures coordination across massive organizations. But there's also danger. The moment doctrine becomes sacred rather than pragmatic, armies stop adapting. And in combat, adaptation is survival. One engineer captain, 4 hours of work, 400 feet of rope. The mathematics were simple, but the implications were profound. Sometimes the bridge you need isn't the bridge you build. Sometimes connection matters more than structure. Sometimes improvisation defeats sophistication. Germany had demolished the Ludendorff Bridge and severed Allied communications for exactly 1 day. Mitchell's impossible rope system reconnected those lines and ensured the demolition changed nothing. In war, as in engineering, the gap only matters if you can't find a way across. The simplest solutions are often the strongest. And the strongest armies are those that remember that truth when doctrine tells them otherwise. If you found this story as fascinating as I did researching it, I'd appreciate if you'd like this video and subscribe to the channel. There are dozens more untold stories from World War II that deserve to be remembered, and I'll be bringing you a new one every week. What should I cover next? Let me know in the comments below.